All right, this lesson is intended to help you do calculations about motors and converting motor horsepower, which you can find on a motor's nameplate, into electrical power, which we typically will measure in kW for billing purposes. So let's get started. First of all, with the equation that helps you or allows you to calculate the amount of electrical kW power by knowing the nameplate horsepower of the motor along with a couple of other variables. The calculation for calculating motor power in kW is taking the nameplate horsepower rating times a conversion factor. There are 746 watts in 1 horsepower, so that means there's 0.746 kW per horsepower. So we'll take that conversion factor and we'll multiply all of this times load factor. Load factor is kind of tricky because it involves understanding the ratio of how much load the power is actually under versus how much it could be loaded at. So load factor can be a little tricky and probably the most difficult to determine when trying to calculate motor power. We're not done with the equation. You need to take all of this information, the nameplate horsepower times the conversion factor times the load factor, and divide it all by the efficiency of the motor. And in the industry, we represent motor efficiency with the Greek letter eta. Okay, so again, this is efficiency. This is load factor here, and this is basically the horsepower of the motor that you're working with. So if you have this information, and we're of course going to go through an example, you can calculate how much power a motor is using. And since this is a class about energy management, we're also going to consider how much power can be saved by replacing a motor with something more efficient. So let's consider we're going to the sledding hill, and there's a tow rope at the sledding hill, and it's our job as an energy manager to determine just how much power the hill could save if they replaced a 10 horsepower motor. So again, we're going to calculate the kW of this motor. We're going to take its horsepower, multiply it times that conversion factor, 0.746 kW per horsepower, multiply that times the load factor. And in this case, the motor will be loaded at about 85% of its capacity, so 0.85 load factor. There's no units on that. And this motor is a standard efficiency for a 10 horsepower motor. It's about 85% efficient. Actually, I reverse the numbers here. I wanted it to be 0.864 efficiency. So let's calculate how much kW the motor is currently using. Okay, and as it turns out, the motor, if you do the math, is using about 7.34 kW of power. Now let's say we replace that motor And when you go to replace it, because federal law requires it, you must buy a NEMA premium efficiency motor. Federal law requires that we only manufacture and sell NEMA premium efficiency motors now. So you found a motor for the sledding hill that is 91% efficient, so a bump up from the standard efficiency. Well, if you recalculate how much power the motor would use at this new efficiency, you'll end up at 6.97 kW for the upgrade of motor. Now, if you recall, we had about 7.34 kW for the last, or the standard efficiency motor. And if we take the difference, that means that there will be a savings of 0.37 kW. Well, that's the same as 370 watts. And of course, if you multiply that times the maybe 2 or 3 rope tows that are on this sledding hill and replace all 2 or 3 motors, that might make a big difference. You can use this information to calculate how much kWh is saved over time. Well, you really have to press hard to get some of these marks off, so I'm going to do my best here. Okay. So again, we have a 0.37 kW saved. And we know that energy equals power times time. So we can calculate, if we know the time, how much energy in kWh will be saved. So let's say that this rope tow runs about 200 hours per season. And if we multiply 0.37 times 200, we'll end up saving 74 kilowatt hours. So we know that commercial electric rates will often include a power or demand rate as well as an energy rate, and now we could calculate for this potential sledding hill customer how much money they could save by replacing just one motor and multiply times 2 or 3 in order to figure out what the savings would be for a full upgrade. Thank you for paying attention. I hope this helped you calculate your motor problems in the future.